Hello everyone, I'm Anurag Gupta from codeItDown. So I'm your trainer for this course. So far we have covered in the linked list, we have covered insertion, insertion at the front, insertion at the end. So in this session we'll cover insertion next. What are the next topics in the insertion of linked list? I hope I'm audible to everyone. Let me share my screen first. Uh, I hope my screen is visible to everyone. Is it? Okay, Venkatesh. Audible. That's good. So should we start? So till now we have covered the insertion part, insertion into our linked list. So let me share my board. So suppose we are given with our linked list, and what we have covered that how we can add a node at the front of our linked list and how we can add a node at the back of our linked list. Up to this, is that clear with everyone, or anybody is having any doubt? Is anybody having any doubt till here? If yes, please ask. If no, please respond on the group chat so that I can move further. Shrey Doshi said, no doubt. Okay, Shrey. So let's move further. I hope nobody's having any doubt. So for today's means session, we'll discuss means insertion in more details. Suppose a linked list is given with us. Let's create a linked list first. I'll again please do not draw anything on the board. Let me remove the permission first. Just wait for me. Okay. Okay. Suppose we have given with a linked list. Linked list. Suppose there are 2-3 nodes are already there. Okay. No audio available. Mahesh, please check your internet connection. I think for everyone else it is audible. Is there anyone else who is having any problem with my audio? Mahesh, please change your chat from private to everyone so that what you're typing, it can be visible to everyone. Okay. Okay, guys, let's draw a linked list first. Suppose again I'm storing an int data for making it simple. Let's say 20, 30, and 40 is given with us. Okay. Okay. Suppose someone has asked us to insert 100. Okay. Suppose someone has asked us to insert 100. Means yes, we had learned how to add 100 at the front, how to add 100 at the back. So let me draw that our head pointer will be pointing to this node and last pointer will be pointing to a null value. Okay. Okay. So suppose someone has asked us to means insert 100 and he has given a value. Means suppose let's say he has said that after 30 add 100. So means we have to add 100 after 30. So what we can do, create a node of and store into its data part store 100. Okay. So he's saying after 30. So 30's next should point to this node now, and its 100's next node should point to 40. Is the question is clear with everyone? Suppose someone has asked us to insert 200 after 20. Okay. So how will add 200? Will add 200 means so 20's next should point to 200 and 200 should point to 30. Is that clear with everyone? Means question, you're clear with the question or anybody's having any doubt? There is one more case. There will be one more case. Suppose someone has asked us to insert 100 after 70. And if we look into our linked list, 10, 20, 200, 30 to 100, 40, there is no 70. So what we should do in this case, if the data is not available in our linked list, we should add our data at the last. Okay, we should be adding 100 at the last. Anurag, remove the link 30 to 40 after adding. Okay, Satyam, this will be removed so that to not create any set of confusion for us. So suppose someone has asked us to insert 100 after 70. So there is no 70 in our linked list, as we can see. So what we'll do, we'll add 100 at the last. Okay. So suppose if the data is not in our present in our linked list, so we'll add the data at the last. Okay. Let's discuss something about the algorithms. What we'll do, there will be one more case. Suppose our head pointer is null. Suppose there is no data into our linked list. So what it should do, it should simply add the data into a node and return the node of that, return the address of that node, so that our head should point to this node now. Okay. So let's discuss something about the algorithm part. How we'll design our code. So first we'll check whether our head pointer is null or not. Okay. Means if our head pointer is null, what does it mean? It means that there is no data into our, if it is null, let's write it n only. So if it is null, it means that there is no data in our linked list. So what it should do, means our, suppose we'll create a new node, its new nodes next should point to null now, because the new node we are going to add, it is in our linked list, it is the first node and the last node. Okay, its next should point to null. Okay, and it should return the address of next node, new node, sorry. Okay, and after that, if head is not equal to null, we should find that, means uh, the data that has given to us, that after which node we have to add. Suppose after 30 we have to add something. So first we'll found 30 in our linked list. We'll iterate through our linked list. First we found 30. If we found 30, we'll add our new node that we have already created. Suppose we'll create it first. So 30's next will point to 100 and 100's next will point to 40. Okay. Let's move to the code, so that means I think after that it will be more clear to you. Okay. So let's move to the code. Let me share my screen. Okay. Let me open my IDE. Okay. So suppose let's first create a struct. I think you all are clear with the structure, because in the last session we have already discussed it. So int data, and the next would be our pointer of node type. Let's name it next. Okay. Let's create a head pointer, and starting it will point to a null value, because there is no, is linked list store duplicates values. Venkatesh is asking, is linked list store duplicates value? Yes, Venkatesh, there is no set of foundation for linked list. Linked list can store duplicate values, because linked list is something that is not given by C++, that is not given by, means any languages for us. There is no foundation, means what we are creating, means we'll set the rules for that, because we have not set any rules, like our linked list should not accept that duplicate values. It will accept. We have not set any foundation for that. Okay. So let's create a function. Why did not you use class instead of structure? Ralte is asking why I'm using structure. Ralte, while solving the question of linked list in C++, we generally use structure, and in Java, we use class and object. Saichan is asking SS. Saichan, please write your question in detail so that we can answer. Okay, let's till now we have created structure only, and we have created a pointer that is pointing to a null value. Okay, so let's create a function that returns a head point that returns an address. Let's store that address into head because it will always return our head node. Okay, let's name our function is add node after. Okay, add node after. I'll pass my head value. I'll pass, suppose add after 25. Suppose add 10. Okay, so it will return a point. It will return a pointer. So I'm right. Return type would be node star. Okay, let's name it add node after. Okay, let's pass our head node to it. Let's call it fval. You can write anything, means after which value we have to add this value. Okay, is that clear with everyone? Okay, so for adding something we need to create means a block, a node. So using node star new node will create a new node and will allocate some memory to it of size node. Okay, so new nodes data will be value. Okay, we'll add this value into our new nodes data, and in the starting we check, means if head is equal to null, so we'll return so what we'll do means that means there is nothing in our linked list. So if there is nothing in our linked list, we should not be checking our fval because we have to add our data. If means there is nothing to in our linked list, we should only return our nodes address. So because it will also be our last node because there was nothing in our linked list, so its next would be pointing to null, because we all know that our last node always point to null and our head pointer points to our first node. So we'll return new node. Okay, what is fval? Aryan is asking what is fval. Aryan, as we have discussed our question, suppose I have to add something in our linked list after 25. There is no 25 because there is nothing in our linked list. Although I'm writing 25, it will not create any impact because in the starting it will check if head is equal to null. Suppose there is something, our linked list is being already being created, and we there is data 25, 30, 35, and we want to add something after 25. So this after calling this function, so 10 will be added after 25. So fval is means we have what we are adding, means what we have showed in our val, that no will means will create the node of that value and will add it after fval. You can name it anything, means I'm writing it fval. Okay, we can write it to position, means we can write some means name it to the position because position will be more understandable, I think so. Is that clear, Aryan? It's the position only, because means after that position we have to add our value. Okay, now we have to go through iterate through our loop. Let's iterate through our loop, because if head is not equal to null, that means there is something in our linked list and we have to check, we have to find now position. Okay, let's try to find position. Before finding position, we have to check whether that node exists or not. Let's try to make it uh, let's make a temporary node star current. I'm making a temporary node name and naming it current, and it will store the address of head. Okay, while because if I want to add something in our linked list, okay, let me draw something on my board. Just wait. Okay, let me share my board for 1 second. Okay, can somebody tell me if I want to add 100 into our linked list and we want to add it after 30, which address we need first, means which node we need to access? We need to access 30. Okay, Is that clear with everyone? Because if we know the address of 30, we can add that data, means we can add 100 after 30. So first we'll try to find 30, whether 30 exists in our linked list or not. So we'll iterate through our loop. So we'll let's check whether current data until the current data is not equal to position. Okay. Well, what we'll do? We'll do current is equal to currents next. Sorry, current is equal to currents next. Okay. And is there is one other possibility that the data, means what if the data does not exist in our linked list, means, so what we'll do, first we'll check whether currents next is not null. uh, Let me draw it again. So suppose I'm finding 70 into our linked list. We know that there is no 70 in our linked list. So with the data, means we are matching with it position. If position is equal to that our current data, the loop will break, because we are writing in it is until it is not equal to the while loop. While loop will run correct finally. Okay. So we need to check one more thing, whether finding, suppose suppose we are searching 70, we'll try to compare with 10, 20, 30, 100, 40, and we don't will not find 70. So side by side we need to check whether after 40 what it will do, it will current will become currents next, so null, it will become null. Okay, because there is no node after 40. So after this, if we try to find means if we try to access the null's data, because null is not pointing to anything, null is not pointing to anything, if we try to access null's data, it will give us a segmentation fault, it will give us a runtime error. Okay. So with this we'll keep on checking that if currents next exist or not. If currents next does not exist, there is no need of checking whether suppose we reach to 40. If the its next is equal to null, that means we don't need to check further. The data does not exist in our linked list. Okay. Let me write the code for it so that it could be more. So if currents next is not equal to null, we'll write and here. If any of these conditions fails, the loop will break. Okay. So if we come out of the loop, that means our loop has already broken. Huh? So we need to check for which condition our loop is broken. So first we'll check if currents next equal to null. That means we have reached to the last of our linked list, and what we say that we did not find position into it. So what we can do, we need to add currents next, because current is pointing to our last node, and currents next should point to currents next should point to new node. Okay. Because now our last node is our new node, because we have to add, if we don't find that position, we have to add it into last. So our new nodes next will point to, now new nodes next will point to null. Okay. Okay. If and it should return head. Okay. If we have reached here, suppose there is something, means this condition fails, this will not return anything, then we'll reach here. That means we have that means currents next was not equal to null, for which condition our loop was broken. Because of this our loop was broken. That means if we came here, that means we have found our position. So currents data is equal to position. It means that let me draw it again. What it means, suppose we are searching 30 and we have find 30 here. we have already found 30 here, and the current is pointing to this node. Okay, so what we'll do first, so our current is pointing to this node. So first we'll store what currents next is doing. Means currents next will be pointing to some node, because currents next is not equal to null. We have already checked that. If it is equal to null, it would have returned something. Okay, let me erase this first. Is anybody having any doubt till now? Let me draw it again. So suppose I have to add 100, and there is a node has been created. Okay, the node has been already created, so our current is currently pointing to this node. Is that clear with everyone? So first we'll create a temp node to store the value of currents next, because we need to store the value of currents next because we have means before updating it. So we cannot directly update currents next. If we update current next, we'll forget the address of this. So first we'll store this into temp. Okay, we'll store it into temp, and after that currents next will point to this node, and after the adding 100 to it, hundreds next will be pointing to temp, because we have already stored it's next to the temp node. Okay, so let me write the code. I hope it is clear with you now. So what we'll do, we'll write node star temp, will create a temp variable, and we'll store the value of currents next here. Okay, currents next has been created. Next has been stored into temp variable. So now currents next will point to new node. Okay, and new nodes next will point to temp. Okay, and after that it should return it. Okay, let's first run our function. So let's try to add a print function so that we can print our linked list. Let's just wait for a minute. I'm writing our print function. Print function we have already discussed in the last section. If still anybody is having any doubt, they can ask him. Okay, while let's say add, let's store it into current first. That is a local variable, it will not make any impact. Let me write current is equal to head. Okay, while current is not equal to null, let me print the data cout current data as well as a space, and current is equal to currents next. Okay, is that clear with everyone? Let me call my function print and pass it to the head node. Okay, let's try to print. Let's try to run. So what it is saying that HEAD we have we have to write, we have written void. It should be, because our head pointer is node of type of node. So 10 is being added. We are asking him to add after 25, but there is no data means into our linked list. There is no 25, so it is being added after at the last, because there is no data, although its address is being means returned with us. Let's try to add. Let's copy this code. Let's try to add some data. This time I'm adding after 10. So 10 is present in our linked list. Now I'm adding after 10. Let's add 26. Okay. So after 10, 26 should be added. Okay, means it is working fine. Let's try to add one more thing. Let's try to add again after 10. After 10 I'm adding. Let's this time add 500. So 10, 526 should be there. That's great. It is looking fine. Let's try to add something after 500. Let's try to add 100. Okay. So 500 is being 100 is being added after 500. Let's try to add after 1000. Means after 1000, let's try to add 89. So 1000 is not there in our linked list. So what it should do, it should add after at the last of our linked list. So our answer should be 10, 500, 100, 26 and 1000 and 89. Sorry, because after 1000 it is asking him to add 89 because there is no 100,000 present in our linked list. So what it will do, it will add at the last of our linked list. So I hope this function is running fine. Is there anybody is having different test cases can enter into a group chat so that I can run that, or anybody is having any doubt with this code, or is everything clear? Please ask your doubts in the group chat so that I can answer. Let me show you the code again. So guys, this is our code. What we have written. Please go through it once again. Is there anyone who is having any doubt? Any doubt regarding this function? Am I audible? Because nobody is responding. Clear, clear. Shrey Doshi is saying clear. Shaisand is saying yes. No doubt. Line number 16. No. Ashish is saying he's having doubt in line number 16. Ashish, in line number 16, I'm not doing anything. I'm just simply creating a current pointer, means just same like head pointer. Suppose it's just like same. Let me write something. Suppose A is equal to 10. Hmm? Again, I'm creating int B is equal to A. What we will store? We'll store the same data that A was storing. Okay. Ashish, I think now it is clear. Yes. Okay. Thank you. So should we move further? Okay. Let me draw one more problem with. Uh, let's discuss something else. Okay. Again, what we were doing. Uh, just wait for. Harshveed, Ashish Kumar, Shay Dosi, I request you to please turn off your please change your chat from private to everyone. Everyone, please type into so means in mode of everyone so that what you're typing it could be visible to everyone. So it's okay. Let's try to discuss one more problem. Suppose we have given with a linked list. The question is same like the previous one. Again, let me draw a linked list 10, 20. Okay, let me write 20 here. Let's say that it is pointing to another node that is 30. Let me add one more node. Okay, let's say 10, 20, 30 and 40 is in our linked list. So our head will be pointing to this node and last node will be pointing to null. Okay, so this time in the previous question, suppose we were given with a node 30 at 100 after 30. Okay, suppose we are adding 100 after 30. This time we have to add before 30. Suppose we have to we are given with a node 30 and a value 100. So this time 100 should be added before 30. So our how our linked list should be looking like. Our linked list should look like this. So 20 should pointing to 10 first, and 100 should pointing to 30, and this node, this link should not be there. Okay, is that question is clear right now? This question is clear with everyone. Suppose we have asked to add add a value 500 before 20. So 500 would be 10 should be pointing to 500, and 500 should be pointing to 20. And in this case, suppose someone is asked us to add before 1000. Before 1000. So in the previous question, if the data is not present in our linked list, what we were doing, we were adding the data at the last, means at the end of our linked list. So in this case, we should not do that. What we should do, suppose we have asked to add, suppose let's say 50 before 1000. So let's say 1000 is not there in our linked list. So what it should do, it should add the data at the front of our linked list. So now our head node should point to this value, and 50 should point to this 10. Is that clear with everyone now? This question you will do, or should I do it? Should I do it myself? Is there anyone who is having doubt with the question, or everybody has understood it perfectly? The question is same, just opposite of the last one. Saichand, you're writing yes, yes. I don't know what is mean. What does it mean? Yes, 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 yes means yes, you understood. Okay, I'm assuming that you understood that question. Uh, okay, Saichand is saying that yes. That's great. So, should we move further, or should I solve this question, or will you do it by yourself? Okay, let me solve it. Let me share my screen with you all. We'll discuss it in group. Okay, Smith. After doing ourselves, as everybody is agreeing with Smith. At last, I have a question. Could you please help me to solve it? Saichand is asking. Yes, Saichand, I will discuss that question. If it is related to linked list, you can ask here, or you can just message me on my WhatsApp number or text me. We'll discuss that. Okay. So everybody has said that you will do that question. So please try to solve that question today itself, and just click a picture of that solution, and try to post it into the group. So try to solve a coding problem. Saichand is saying a coding problem. Okay, Saichand, just share that link with me. I'll check that question. If I'm able to solve, I'll let you know. Okay. So I think we have covered the insertion part. Let's move to the another topic, that is deletion. Okay. So should we start deletion now? Let's again. What we'll do? Suppose Saichand, you're saying chessboard, and it is NQN problem. Okay. Okay, Saichand, just share a link of that question. I'll go through it. Okay, Saichand, please share it into on my WhatsApp number after this class. Okay, we'll do that. Don't worry. So suppose we have given it the linked list, and let's again suppose there's some data has been given with us. So suppose we have given with the data, we have given with the linked list, and our head is pointing to this node, and it is our first node, and our last node would be pointing to a null value, a null pointer. Okay. Okay. So what we have to do in this question, so we just We simply have to delete our first node and our head should point to our next node. Suppose we want to delete a node from starting of our linked list. Okay, so let me write a function that head delete. It should return a pointer. That's why I'm showing it into head. Delete from front. Okay, and head will be given to head. Okay, uh, this will return a pointer. So its return type would be node star. And let's we have named it delete from end. Delete from the front node star our head node. Okay, so what we have to check into this function before deleting something, let's check whether something exists in our linked list or not. Suppose someone is trying to someone has passed a null value to our link or to our this function. So first we'll check whether head is equal to null. If yes, if head is equal to null, what it should print a message that there is nothing to delete. There is nothing. Okay, there is nothing to delete. Okay, and it should return that head pointer. Is that line is clear with everyone? Okay, let's write. Let's put it further. And if head is not equal to null, that means in our head something exists. Means in our linked list something exists, and we need to delete that head value. Means that head node, and our head should point to the next node. So before deleting something, as a good programmer, means we should delete that memory. Means suppose while inserting something in our linked list, we are allocating memory to our node now. So before deleting some node from our linked list, means after deleting something will free this memory. Means this block means will let my computer know that this block has been freed, you can use it for anything else. So what we'll do, our head should point to our heads next. Oh, and if we'll update our head is points to our heads next, and if we want to delete our head now, because we have lost the value, we have lost the address of our head node. So what we'll do, we'll store it into a temp variable. Okay, we'll name it head, sorry, into our temp. We'll store the address of head, and we'll delete sorry, after updating head is equal to heads next, and in our temp that this node's address will be stored. So we'll delete temp. Okay, so this node this block will be freed for our program. So after that, let's return head. Okay, is that clear with everyone, or anybody's having any doubts with this code? It is very simple code, I think so. So let's try to delete something. Suppose in our linked list there was 10, 500, 100, 26, 89. It is being recorded. Uh, Manish, yes, it will be recorded and it will be uploaded on YouTube. We will get the link of that session, this session. Okay. So let's try to delete something from our linked list, and the 10 should be deleted because we are calling our function one time only. So 500, 100, 26 and 89 should be there. Okay, that means it is working fine. Let's try to delete one more element. Okay. So again, it has been deleted. Means it is working fine. Let's try to delete 100 also. So 100 is being deleted. Let's try to delete it from here. Let's try to delete something from here when nothing is in our linked list. So what it should do, it should print a message there is nothing to delete, because after creating a head pointer that is pointing to a null, where after that we are calling our delete from end function. means delete from front function. So if there is nothing in our linked list, what it is printing, there is nothing to delete. Okay, is that function is clear with everyone? Or anybody is having any doubt? Mank is saying it is clear. Okay, if it is clear, so we should move to our next topic. So I'm assuming that it is clear with everyone. So again, can't we just change the reference of head to heads next? Aryan is asking, can't we just change the reference of head to heads next? Aryan, we are just changing heads to reference of head to heads next in this line. But before changing it, so there will be no need of temp. Yes, Aryan, there is no need of temp if we remove this line and if we remove this line. So there will not be any effect on our program. So again, the output is same. But as a good programmer, what we should do, suppose before adding, means before inserting something to our linked list, what we are saying that we are creating a block, means a node, and we are allocating some memory to it. So what our responsibility should be, so there is this, all this we are writing is a very, means limited, means we can say very small programs we are writing, means it is not taking that much of memory. But if we write, means if we write linked list of, means let's say 1 million nodes, so what we should do means after deleting, means we know head will point to heads next, so this node will still be present in our memory now, means this node will still be present. So what we should do, we should free this memory, means we should delete this memory, so that this block should be freed and it should be, means used for the further use, means it should be used by somebody else in future. Okay, okay, so that's why I was writing temp, means storing the address of that head node into temp and deleting the temp after that. Okay, again, so what we have covered some to delete something from front. So what we'll do, we'll delete something from our end now. Okay, delete from end. Delete from end. Okay, let's remove all these. So just try to print our linked list first. So in our linked list, 100, 10, 500, 126 and 89 is there. So what our need is, so after calling this function, this 89 should be deleted. Okay, so again it will return a head node, means a head, means pointer. So return type would be node star, delete from end, sorry, delete from end. Okay, just wait for a second. Okay, delete from end, and its node will be pointing to, sorry, head pointer will pass through it. Okay, we'll again check whether head is equal to null or not. If head is equal to null, that means there is nothing to delete. Okay, so simply it should print a statement that there is nothing to delete. Okay, slash n, and it should return a head pointer. Is that clear with everyone up to here? So suppose we have given with our linked list 10, 500, 100, 26 and 89, and we want to delete 89. We want to delete 89. So which means for which node we want to access, means we want to access for which node. If we found the address of 89, can we delete 89? Yes, so Venkatesh is saying 26. Yes, Venkatesh, you are absolutely right because 26 is pointing to 89. So for deleting 89, what we should write means it should 26 next should point to null, because if 26 next would point to null, so that means we have means end our linked list, means we have reached to end of our linked list. Okay, is that clear with everyone? So while currents next, not currents next, it should be currents next, uh, because if its next would not be null, means we should iterate our loop up to where if its next means 26 next should be 89, 89's next should be null. So what I'm checking, if currents next means tens next means if we want to access tens next, what we'll get the address of 100. If we want to get the means what if we want to access 500's next, we'll get the address of 26. Okay, we are checking whether it is equal to null or not, means if it is not equal to null, what we should do, uh, first we have to create our current node, because we cannot change our head pointer because we have to return our head pointer as well, huh? Okay, so what it should do, so let's say currents next is not equal to null, so it should be current, it should be equal to currents next. Okay, is that clear with everyone? Means where our loop will break, our loop will break at 26, because 26 next is 89 and 89's next is null. What it will check, uh, if suppose current is pointed to 26, 26 next would be 89, 89's next would be null, means if current's next would be null, this loop will break. Okay, and if now our current node is pointing to 26, huh? So again, as a good programmer, which should show the address of 89, means currents next, because we want to delete the currents next, huh? Okay, and currents next should point to now, it should point to null. Okay, is that clear with everyone? Because suppose our current is pointing to 26 and now 26 next should point to a null value, because we want to delete 89, so 26 next should point to our null value. Okay, and we should delete our temp, because in temp 20 currents next is stored, means the address of 89 is being stored, so we'll delete temp here, we'll return our head node here. Okay, what it is saying a segmentation fault, line number 4, in line 4. Okay, I understood. Can somebody tell me why the segmentation fault is coming? Head is equal to null, head is equal to null. Ralte is saying if head is equal to null. Acha, okay, okay, head should be equal to null. Okay, so it is being deleted. You're right, Balta. So 89 has been deleted. So let's try to call our function again. Sorry, it should be end, delete from end. What it should do, it should delete 26, no? If we delete temp, it will only delete the address of 89, not stored value. Ashish Kumar is asking that 89 not the stored value. uh, Ashish Kumar, in C++, that delete, what delete will do, delete will completely free this node. in the node means if we passing address of means we are writing delete and some address, so it will completely free that address. And suppose if we are writing new and that address, and we are writing new and that address means it was creating a memory for that, so as like that it will delete that memory completely. So the value and the next node, for the complete node it would be deleted, not only that address. Okay. So Ashish Kumar is saying he's got. Okay. So again, if we're writing head again, so what it should print? It should print 10 and 500. Okay. Is there anyone who is still having any doubt into our code? Means what we have written, or is that clear with everyone? Is that clear with everyone? Smith is saying clear. That's great. Ralte is saying clear, but I'll say that there is something wrong in our code. There would be some test cases in some in that test cases it would run, it would not run correctly. Everyone is saying clear, clear, clear. So let me create that uh, test case. Suppose it will run fine if there is nothing in our linked list. So it will just print if there is nothing in our linked list. If we try to delete that node, so it is printing that there is nothing in our linked list. So again, let me write this first. Okay, let me comment it out. Let's let me comment it out well. So let's try to print this first. So 10, only 10 is in our linked list. Okay, is that fair with everyone? So if I want to delete that 10, hmm, let's call delete from end. Let's store it into our head. Okay, let's delete. Let's try to delete head. So a segmentation fault is coming. Can somebody tell why this segmentation fault is coming? That means we have not written, means there is some test cases. If there is only one data in our linked list, it is not working fine correctly. So if we two times next, Mank is saying two times next. Yes, Mank, you're absolutely right. So what we, if we try to solve or means these type of problems onto some online platforms, they what they do, they create some test cases, boundary test cases. Means what we say that we have completely written our code fine, but it was saying that some segmentation fault, and all the test cases were not running fine. So every time you write some code, just try to check it for every possible test case. So what the problem is coming? Let me first draw that. Bank has understood, I think so. Let me draw this node. Suppose what in our linked list is, suppose there is 10. Okay, and our head is pointing to this node, and its next is pointing to null. Okay, so its next is pointing to null. Okay, so what our code will do, let's try to run through it. So if in the starting it will be null, 10 will be added for from this function. So if we try to delete 10, so this function will be called delete from end. So what delete from end will do, delete from end will check if head is equal to null. No, head is pointing to some node, head is not equal to null. So this condition will not run, this condition will not run, it will not be satisfied. So what it is saying that store into current the heads, means address of head, store into it current, a current pointer. So a current pointer is being created. Let me write, a current pointer is being created. Okay, and current is pointing to this node, and head is also pointing to this node. Okay, there is 2 pointers. Suppose let's take it head h, let's take it current. Okay, that current and head both are pointing to this node only. This let okay. So what it will do, it is saying that current's next. So current is pointing to this node, its next is null, and it is checking null's next. If we in our code, if any time if we try to means access null's next or null's value, will get a segmentation fault. So what it is trying to check means it is trying to check means currents next means null's next. If we try to access null's value means null's data, will get a segmentation fault. Is everybody is clear with the means clear with this doubt? Why we are getting this segmentation fault? Then we'll try to remove this segmentation fault. Or anybody is having any doubt still? To anybody, please repeat. Saichan is saying, please repeat. Okay, Saichan will repeat it again. Don't worry. So in the starting, we are having a linked list. Our head is pointing to this list, and this is our first node as well as the last node, because head will point to this node, and into its data part, the 10 is being showed, and into its next part, the null will be there because it's the last node also. Okay. So if we call this function for this head, it will check if head is equal to null, that if head is not equal to null, head is having some address of this node, head will not be equal to null. So what it is saying, that create a current pointer. A current pointer will be pointing to this node. Okay. So after that, what it is saying, that currents next will point to currents next. So current is currently pointing to this, and currents next is pointing to null, and it is asking next means currents next. So what we'll do, let me okay. So what it is saying, our currents next is null, and null's next it is asking. So as we all know that we cannot access null's next or null's value, because there is no memory there. Memory is not being created, any memory is not there now. Means null is what? Null is nothing. So if we try to access null, the memory is nothing is there. Null's next will not get any value. Will get our segmentation fault. If we try to we'll try to fetch the value of null's next or null's data. Okay. So null's next we cannot access this value. Means currents next we cannot compare it with anyone. Means with anything else. Means with anything, because there is nothing in currents next, although null is not there, because null's next we cannot access. And this statement is making this code means making a segmentation fault here. Means currents next. Saison, is this clear now? The problem means why we are getting segmentation fault. It simply means we cannot access null's next or null's data. Okay. Okay. What are the solutions of this problem? Either we can write here, either we can check here, if heads next equal to null. Okay. If heads equal to null, that means only one value is there. Only one value is there. Okay. So what it should do, it should delete that head and return a null value, because we know the address of head, and after deleting this node we don't need any address, because if there is only one node, what it should return, it should delete that node and it should return a null value, because in our head it should show that null. If null is stored in our head, that means there is nothing in our linked list. So that means our code is working fine. So let me comment it first. So at the starting we are having 10. If we're trying to delete 10, 10 is being deleted. Okay, I think now everybody is clear with this problem. Okay, is anybody still having any doubt? Okay, means our code is running fine. If anybody is having any different test cases or he's thinking that for this test case it will not run fine, please type your test case so that I can run and I can show you that so that we can check whether it works for that or not. I'm assuming that nobody's having any doubt, or is there anybody who is having any doubt? There is one more way of doing this. Uh, Instead of this code, let's. I'm thinking one more solution. Let's try to check before next if currents next is equal to null or not. Means let's check whether currents next is not equal to null. Just check here and double end. If this condition fails, means currents next is equal to null, it will not check this condition. Okay. Just wait, I'm running this code. Let's see whether this runs fine or not. It is saying there is some problem. Let's try to run it again because it is not giving any error. I think there is some problem with this ID. Let's try to run this on another ID. Okay, yes, for this it runs perfectly. Let's comment this out. Let's see whether 10 is being deleted or not, because we are having a problem with this test case only. I think there is some internet issue at my place. So it is saying there is some problem. Let's try to run it on another. Let's try to run it here as well. Just wait for a second, guys. I think there is some internet issue. It is saying there was some problem with this, but the product is not. Okay, guys. Just try to check with this code, with this statement, whether it works fine or not, and do let me know in the group. And just try to click a picture of that. If you are getting some error, just try to click the picture of that error and paste it into post it into the group so that everyone can understand means what is the problem that we are facing into this. Okay, guys, for 2 days I'm ending this session. Means I'm ending it early today. We'll meet day after tomorrow very soon. Means most probably it will be day after tomorrow with a new topic. We'll cover in that we'll cover delete if a node is given. Means suppose 10, 20 and 30 is there and we have to delete 20. Someone has asked us to delete 20. How we can delete 20? Okay. Saichan, you are asking WhatsApp number. Saichan, just check just check into group. There into the group. Anurag Gupta. My name is Anurag Gupta. You can just message me on that group. Okay. Uh, okay, guys. I think everything is fine. So we'll meet soon on day after tomorrow, most probably. Or anybody's having any doubt with the 2 days what we have covered today? Today we have covered means if the node is given, if we have to add something after that node, and one question I have given you that if we want to add some data before the given value, and that if the data is not present in our list, we should add it at the front of our list. Okay. Try to solve this question. If you are able to solve, that's good. Otherwise, try to discuss this question into the group. Or if you are facing any type of error or any type of some sort of runtime or compile time error, so try to click the means picture of that error and just send it to me. I'll see it and I'll let you know what are the problems that we are doing. Okay. I think rest everything is fine with everyone. Hmm? Or do anybody is having any doubt regarding linked list? Okay, I'm ending today's session. I'm assuming that there is no doubt, nobody's having any doubt. So, guys, I repeat again that try to come up with some problems that, as Saichand has came with some questions, try to come with some questions. Means either it could be related to this topic or it can be some out of that topic. It does not means we'll try to provide you support from anybody who is able to solve that question or that problem in our team. Okay. Just solve maximum number of questions. A set of questions will be shared to you guys again today, means and try to solve the maximum number of questions from that set and try to discuss that questions into the group. Okay. And this Sunday, hopefully, we'll arrange a session, means doubt clearing session and means problem solving, means the question that we are giving to you will try to discuss the questions if you are having any doubt with that questions on Sunday. Okay. So till Sunday, you are advised to means solve the maximum number of questions that are being provided to you. I think is that clear with everyone? Can somebody respond it on the group chat so that I can end the today's session? Aryan, you're saying yes. Okay. Smith. Okay, guys, and try to provide some feedback regarding sessions that how the session is going. Means if you are having any problem, any sort of communication issue, or means the session is not that much interactive that you as you have means assumed. Means try to give some feedback on the group. Okay. Okay. I'm assuming all clear. Okay. Thank you everyone for attending today's session. Happy learning. Stay home. Stay safe. Thank you. Thank you everyone.